Dear students, today we discuss about Einstein coefficients. So why do we study these Einstein coefficients? So Einstein coefficients are useful to describe the interaction between photon and matter. And not only that, so we can study deep understanding about absorption and emission process at atomic level. So we can see here, so there are three processes. One is absorption, one is spontaneous emission, next third one is stimulated emission. We can see here, so the ground level energy level is E1 and higher level E2. So if photon is falling on that electron, so the electron absorbs energy and goes to the higher level. So here RAB stands for rate of absorption. This rate of absorption is proportional to number of atoms which are present in ground level. Here number of particles at higher level N2. Again, so whatever energy density is E of mu. So rate of absorption is proportional to N1 and E of mu, that is energy density. So if I remove this proportionality, so we can give constant, so that is B12. So suffix 12 refers from lower level to higher level. So RAB, rate of absorption, equal to B12 N1 E of mu. So whereas spontaneous emission, so there is no requirement of extra energy, so this atom falls on ground state. So ground level is E1, higher level is E2, number of particles in ground level N1 and number of particles at higher level N2. Rate of spontaneous emission is proportional to N2, which particles are present in the higher state. So the constant A21 into N2, this A21 we call it as spontaneous emission coefficient. So whereas stimulated emission, so when we give some extra energy, that is H nu, so then this atom is falls from higher level to lower level. So the ground level energy is E1 and higher level energy is E2. Number of particles in ground level N1, number of particles at higher level N2. So the rate of stimulated emission is proportional to number of particles in higher level and energy density. Then if we remove this proportionality constants, B21 N2 E of mu. So then under thermal equilibrium, so number of upward transitions is equal to number of downward transitions. So there are upward transitions is only one, whereas downward transitions is spontaneous emission and stimulated emission. So RAB means rate of absorption is equal to rate of spontaneous plus rate of stimulated. So N1 E of mu B12 is equal to N2 B21 plus N2 E of mu B21. So if I take E of mu, which is energy density, if I take common, so then we will get E of mu is equal to N2 A1 divided by N1 B12 minus N2 B21. So then if I take common from denominator N2 B21, we will get E of mu is equal to N2 A21 divided by N2 B21 into N1 B12 divided by N2 B21 minus 1. But we know that from Boltzmann's relation, N1 by N2 is equal to E power h nu by kT. So this N1 by N2 we need to substitute in equation 2. So then we get E of mu, energy density E of mu is equal to A21 by B21 B12 divided by B21 into E power h nu by kT minus 1. So from Planck's distribution formula, we can write E of mu is equal to 8 pi h nu cube by c cube into 1 by e power h nu by kT minus 1. If I compare equation 4 and 5, so we get B12 divided by B21 is equal to 1, and so from this equation we can write B12 is equal to B21. So from this equation we can say that so the spontaneous emission is equal to stimulated emission, and not only that, we can conclude that A21, which means that spontaneous emission is proportional to nu cube.